Hey everyone, welcome to the Notes on Radical Review. So today we're going to do some review on simplifying radicals, but some things that we're going to do, like example B up here, is going to be brand new. So you're going to have to pay very close attention. All right, so when you're simplifying radicals, one of two things has to be true. The radicand, aka the number underneath the radical sign, cannot have any perfect square factors. So something such as square root of 8 is not simplified because 8 has a factor of 4. The other condition is that you cannot have radicals in the denominator. If you have radicals in the denominator, you have to do a little bit of messing around with the problem in order to get the radical out. All right, so example A right here is 2 divided by the square root of 3. Now that radical 3 cannot be in the denominator. If it is, that is considered not simplified. So what we have to do, and we've done this before this year in this class, is we have to rationalize the denominator, okay? So how we're gonna do that is we are gonna go ahead and multiply the top and bottom of this fraction by square root of 3 over square root of 3, because this simply equals 1. If I multiply by radical 3 over radical 3, that simplifies to 1. So yes, I am changing how this radical looks, but what I'm not changing is its value. As long as I multiply by 1, I'm not changing any number's value. So my numerator, 2 times the square root of 3, is just 2 root 3. Divided by, what this is going to end up being is the square root of 9, because the square root of 3 times the square root of 3 is the square root of 9. Now, square root of 9 is simplified to be, because 9 is a perfect square, it is just 3. So our final answer is 2 root 3 over 3. This step right here, when you do radical 3 times radical 3, you could just go ahead and write that as 3, because squaring a square root, which is what we're doing here, we're taking a root and multiplying it by itself, is always going to unsquare root it, I guess, right? So like square root of 3 times square root of 3 is 3. Square root of 7 times square root of 7, 7. You're always releasing the number from the radical. Example B over here is something that we have never seen before, because now our denominator is not simply a monomial, just one term, it's a binomial. There's 2 terms. So what you're going to have to do to get that radical out of the denominator is multiply top and bottom by something called the conjugate. You will do more with the conjugate next year in Algebra 2, but what a conjugate is, when you have a binomial, the conjugate of a binomial means you're just going to switch the middle sign, not side. So for this problem here, we're going to multiply the top and bottom by the conjugate of the denominator. So the conjugate of the denominator is going to be 5 plus the square root of 2. Nothing but that middle sign changes. So what I end up with in my numerator is 3 times 5 plus the square root of 2, we are going to simplify that in a second, over, and then I'm going to have my binomial, that was my original denominator, times this new conjugate that I'm multiplying top and bottom by. What's left here is we're just going to have to multiply through. So in the numerator, you're going to distribute 3 times 5 and then 3 times the square root of 2, giving us 15 plus 3 square roots of 2. And in the denominator, you're going to FOIL it. So 5 times 5, 25 first. Outside, plus 5 root 2. Inside, minus 5 root 2. And then the last times last is going to be minus the square root of 4. At this point, you're going to clean up anything that you can in the numerator if possible. If not, that's okay. The denominator, you are always going to be able to get rid of some things, because, okay, 15 plus 3 root 2, nothing I could do with that. So I leave my numerator. My denominator, notice what happened. My outside, inside, because I took a binomial and multiplied it by its conjugate, what is going to happen 100% of the time is your outside and inside cancel each other every single time. And so then what I'm going to have is 25 minus the square root of 4, which is 2. So I could keep going with that. I could clean that denominator up, and my final answer is going to be 15 plus 3 root 2 over 25 minus 2, which is 23. Again, anytime you have a denominator that is a binomial with a radical, you have to multiply top and bottom by the conjugate and then just simplify. Do some algebra, some distributive properties, some foiling. I showed a lot of steps here that you're maybe going to, as you get used to these problems, you don't have to do all those. Okay? All right, so the rest of this is just, we're going to go through, I'm going to do some of these problems, and then I'm going to leave the rest of them for you to do as your assignment. So the first one, what we have here is the square root of 32. We have done this many, many, many times in this class. So when you simplify it, depending who your teacher is, but you want to rewrite this as what perfect square goes into 32? 4 does, but if I think of 4, in my head, I'm thinking, okay, that's 4 times 8. 8 still has a perfect square. So that's not the biggest square that's perfect underneath there. If I do that, that's like simplifying twice. That's okay. I always like to take out the biggest one possible. So to me, I see that that is, whoops, don't want to use the highlighter, 16. 16 times 2. The square root of 16, 16 is a perfect square, so what that's going to equal is 4, and then square root of 2 stays underneath the radical. Okay, I want you to try number 2 on your own. We will do number 3 together. So for number 3, there are multiple ways you can do this. When you're multiplying radicals, you could either simplify first and then multiply together, or sometimes, and as this becomes more intuitive for you, you're going to see that, okay, if I multiply these together, I'm going to end up with the square root of 500. And I did it that way because I know 100 is a perfect square. So I would rewrite this as the square root of 100 times 5. Circle the 100, it's a perfect square. What releases? A 10, okay, because the square root of 100 is just 10 square roots of 5. Again, the way I write this in my class is I say, okay, rewrite the square root of 100 times the square root of 5. Square root of 100 is a weird way to write what number? 10 root 5. But you get the same answer either way, and depending how your teacher taught you. All right, I will leave number 4 for you guys to try. Right, number 5 over here, we have square root of 6 times square root of 6. Again, I see this and I think, okay, if I multiply these two together, I get the square root of 36, because 6 times 6 is 36. Square root of 36, because 36 is a perfect square, it's just going to equal 6. All right, number 6 is for you to try on your own, and we'll do number 7. When you see a fraction, a couple things you should always look for, especially if the radical is over the entire fraction. You should look and see, are either of the numbers, the one in the numerator or the one in the denominator, are either of them perfect squares? If yes, fantastic. If not, double check and see, can I reduce this fraction? Because if you could reduce it, a lot of times that'll make your life a lot easier. But this, I see that this is the square root of 81 over the square root of 49, because as long as the radical is over the entire quotient, you could separate the square root signs. Square root of 81 is 9 over the square root of 49 is 7. Done. Dun, dun, dun. Number 8 is all you. All right, number 9. Square root of 63 over the square root of 8. All right, well, there's a couple ways to do this problem. First of all, neither of these are perfect squares. 63 is not, 8 is not a perfect square. So there are a few ways you can do this problem. First way, you can go ahead and multiply top and bottom by the square root of the denominator, right? Because we have to rationalize this radical. So I would multiply top and bottom by the square root of 8 over the square root of 8. What does that give me? Kind of big numbers, so I'm not thrilled with this. It's the square root of 504 over square root of 8 times square root of 8 is just 8. Okay, so factors of 504. Maybe we're not so familiar with them, such as factors of 24. We know what perfect square is in there. Or factors of 120, we could see what perfect squares are in there. 504 is not as, I don't think, intuitive, but so if you use your calculator, you could find them. But what this ends up being is the square root of 36 times 14. Because 504, 36 is a perfect square. It goes in there. It's over 8. So now, square root of 36, we can circle that. It's a perfect square. A 6 escapes. We're left with square root of 14 over 8. Now, can I simplify this? Yes, I can. What I could simplify are the two numbers that are not inside the radical. The 6 and the 8, those can be reduced. And that's only because it's a monomial on top and a monomial on the bottom. There's no plus or minus signs anywhere in between these numbers. So if I reduce this, it's 3 root 14 over 4. Okay? Now, I'm going to do the same problem, but I'm going to do it in an alternative way because square root of 63 and square root of 8, as you saw, 504, that became a little tricky. So what I'm going to do instead is I'm going to simplify each of these individually. 63, I look at that and I know 9 goes in there. 9's a perfect square. It's 9 times 7. Square root of 8, I look at that and I think, oh, okay, I know what goes in there. 4 goes in there. And then it's 4 times 2. Bless me. Haha, just kidding. Okay, so with this 9, it would be a 3 root 7. And then with this, it would be a 2 root 2. But we still have the issue of having that radical 2 in the denominator. So what I would have to do is conjugate, not conjugate, but rationalize square root of 2 over square root of 2. My numerator becomes 3 root 7 times root 2 is 3 root 14 over 2 times the square root of 4, which we know is a number that's going to escape, right? It's going to get out of the radical, and it's 3 root 14 over 2 times the 2 that escapes, 4. Is there one way that's better than the other? I don't know, but notice that we do get the exact same answer, right? So those are a little bit trickier when the numbers get bigger. But I don't think it's anything you kids can't handle. All right, number 10 is for you, and then I will actually do 12 because it's a little bit trickier than 11. So I'll do 12 with you, and you kids can do 11 for your homework. All right, so the last one here. Now we have a binomial in our denominator. So this is similar to the top problem that we did, where we have to multiply top and bottom by the conjugate of the denominator. Now the conjugate is only when you have a binomial meaning two terms, and then we switch the middle sign. That's the only thing that we switched. We changed the middle, right? Instead of being a minus here, we are now multiplying by plus. And now 5 plus 2 root 6 over 5 plus 2 root 6, I'm not changing this fraction's value at all. I'm just changing how it looks. So in the numerator, I would have 7 root 3 times 5 plus 2 root 6. In the denominator, I'm going to have binomial times a binomial, so I'm going to have to FOIL this. Okay, numerator, let's multiply. 7 root 3 times 5 is going to equal 35. 7 times 5 is 35 root 3. Remember, you can multiply numbers that are not in the radical with numbers not in the radical, radical with radical. So 7 root 3 times 2 root 6 is going to be plus 14 square root of 18. Because root 3 times root 6 is square root of 18. In the denominator, first times first, we're FOILing 25. Outside, plus 10 root 6. Inside, minus 10 root 6. That's a good sign. Your outside and inside should be opposites. Minus, my last times last. 2 times 2 is 4 square roots of Let's keep cleaning this up. In the numerator, I am going to get 35 root 3 plus 14 square root of 18, I see has a perfect square of 9 times 2. Over these two, outside, inside, cancel each other out. What I'm left with is 25 minus 4 square roots of 36. Almost done. My numerator, excuse me, my numerator is going to become 35 root 3. There's nothing I can do with that. But my 14 times 3, because square root of 9, a 3 is going to be released. That is plus 42 square roots of 2. That's all. That's all I can do up top. Those are two different numbers underneath the radical sign. That means I can't do anything with it. On the bottom, what I'm going to have is a 6 that escapes here, right? Square root of 36 is 6. So 25 minus 24. So my final answer here is 35 root 3 plus 42 root 2. All right, the ones that we didn't do together, please finish that up for homework for yourselves. We will check it in the next time that we meet. Thank you again for watching. Have a great day.